So today we are here to solve our daily lead code challenge for the day. Today's challenge is find champion. Find champion 2. And as we all are champions, it is, mandatory for us to solve this problem. So in order to solve this problem, first of all we will go through the problem statement, okay? And then we will go through, you know, take a deep dive on this. So let's concentrate on the problem statement first. So it's saying that there are n teams numbered 0 to n minus 1 in a tournament. Okay, there are n teams numbered 0 to n minus 1 in a tournament. Each team is also a node in a DAG. What is this DAG? DAG is directed acyclic graph. Okay, the full form of DAG is directed acyclic graph. So a graph in which there is no cycle and that is directed as well, that is DAG. Okay, and then you are given an integer n. Okay, so as an input we are given the integer n and 0 index 2D array edges of length m. See, the integer n is given and m's edges length is m. They are not same. Notice this thing. Okay, you are given an integer n and a 0 index 2D integer array edges of length m representing the DAG. Okay, where edges I is equal to ui vi. Ui is the starting node and vi is the ending node. So as we know, in any directed edge there is one starting vertex and then there is this ending vertex. So ui represents the starting vertex here and vi is representing the ending vertex. Okay, so this ui vi indicates that there is a directed edge from team ui to vi in the graph, but the directed edge has a meaning to it. And what is the meaning that we are associating with the directed edge? What is the, how we are, modeling this thing using the graph? So in this context, the directed edge from A to B in the graph means that the team A is stronger than the team B and the team B is weaker than the team A. So if team A is stronger than team B, definitely team A is going to be, winning over the team B. Okay, so it is saying that team A will be champion of the tournaments if there is no team B that is stronger than team A. So it is saying that if there is a node in the graph such that there is a directed edge from that node to all the other nodes, okay, then definitely team A will be the champion. Okay, and this could also be that, see in this diagram, see from node 0 to 1 there is one directed edge. So node 0 is stronger than this team represented by node 1 and node 1 is stronger than the team represented by node 2. Why? Because there is a directed edge from node 1 to node 2. Okay, so this is there and then this is there. So 1 is stronger than 2 and 0 is stronger than 1. So overall 0 is the most stronger team. Okay, and that's why we are returning 0 here. Okay, and see in this example, see 1 is stronger than 3, 1 is stronger than 2, but 1 is, the lack of directed edge from 0 to 1, we are not able to conclusively say that 1 is stronger than 0 as well, but we can conclusively say that 0 is stronger than 2, and in between these two, 0 and 1, okay, see, only if we consider this part of the, only if you consider this part of the graph 1 3 2, then 1 is the clear winner. But in addition to 1 3 2, if the node 0 is also considered and there is a directed edge from 0 to 2, so node 0 is also a winner, but we cannot conclusively say in between 1 and 0 who is going to be the winner. Okay, and that's why we are returning -1 here in this example. Okay, so here it is saying n can be in between 1 to 100. Okay, and m is the edges length. Okay, and m is less than n into n minus 1 by 2. So it means the number of edges in the edge array is less than n. okay. And also it is mentioned that the zeroth vertex is never the same as the second vertex, is the never is the same as the first vertex is never the same as the second vertex in the edges graph. So there is no loop, self loop kind of thing. Okay, so how are we to answer this, you know how are we to answer this? So in order to answer this, we will see, as soon as we see DAG and then this kind of thing, the thing that comes to mind is topological sort. Okay, and we know that to solve any problem using topological sort, we can use either depth first search or the Kahn's algorithm. Okay, but here I would say that you need not even implement topological sort to solve this problem. What you need to do here is that first of all you need to declare one uh, n degree an array called n degree. Okay, and then what we'll do, new int n. So this is the n degree. Okay, and then what we need to do declare is that one count variable and then one champion. So this champion is going to store the champion team. Startingly we will put the value -1. Okay, and now since this is given here, that see, in this case n is 4 and edges are 3. So it could be possible, okay, if it could be possible that if n is equal to we will discuss these things later on. Okay, and now first of all we need to find the n degree of each and every edge. So to find the n degree of each and every edge, what we will do, we'll take the individual edge, okay, out of these edges, individual edge out of this edges array, and then n degree of edge of 1 will be incremented. So okay, so this n degree of this will be incremented. Now we will go through this n degree thing. After finding the n degree of each and every vertex in the graph, what we will be doing, will be going through this, and what we'll be doing, if n degree of I is equal to 0, okay, then what we'll be doing, we'll be incrementing this count. Okay, and then what we'll be doing, champion will be designating the champion to be the ith. And also it could be the case, see here, in this case 1 is the is the stronger than, there is no n degree at 1, because from 1 there is a vertex to 2, from 1 there is a vertex to 3, so there is no n degree at node 1, because node 2 has 2 n degree and node 3 has 1 n degree, and also similarly is the case with the node 0, there is no n degree. So it could be possible that the two nodes have 0 n degree, and in that case we are returning -1. So we need to figure that as well. If n degree, or we can say that if count is greater than 0 and n degree of I is equal to 0, then simply will return -1. Okay, and after this what we will do, will return champion. Okay, this is done. But see, there are some edge cases. Okay, and what are the edge cases? It is saying that the number of edges is less than the number of these things, the number of nodes. Okay, so we need to figure that as well out. Okay, and what is that? So if n is equal to mm, we will, I think we will figure that out after we run this solution. Perfect. So let's submit this out. Perfect. Perfect. Okay. So this is the way to solve this problem. I hope you liked it. See, if you read the problem statement, it may look like very difficult, so many constraints, so much, diagram and all these things. And if you consider this, only one loop and one check loop. Okay, so this is the setting up, this is just finding out, figuring out the n degrees, and this is the checking thing. So only with these two things we are able to solve this, monstrous looking problem. And since we are able to solve this problem, we are the champions. Best wishes to you, everybody. Happy coding. Keep rocking.